Hey everybody, so today we're going to start talking about using the wrong pen. Well, that's what we're going to start talking about. Electrophilic aromatic substitution. Or, as it is called in lazy chemist parlance, EAS. Okay, the thing about EAS is there are probably 10 to 20 different electrophiles. There are many of them. But regardless of what they are, the electrophilic aromatic substitution mechanism itself is actually the same in all of them. Any variation takes place before you get into the aromatic ring. Now, EAS reactions all follow the same pattern. 1. Generation of a strong electrophile. No measly, wimpy proton will do. We're talking carbocations here, if not more energetic than that. 2. Addition to aromatic ring. This is actually the rate determining step, folks, because with the EAS reaction, the first thing you're going to do is break up your aromaticity, which, remember, is that tremendous stabilizing force. Now that you don't have the option, once you do this initial addition, that is a higher energy state. The activation energy is pretty significant, which is part of why you need a strong electrophile to pull this off in the first place. Option 3 is resonance. Actually, 2 to 3 different resonant forms that come out of this. And finally, 4th is an E1 type elimination. I say E1 type because it may or may not truly be an E1. It really depends on who you ask. To regenerate the aromaticity and make it stable again. All right, so with those words under our belt, let's take a look at what happens here. All right, there's the aromatic ring, there's the electrophile. Really quick reminder, I'll put it down here in this corner. The aromatic ring, if you look at it from the side, so pretend that is a side view, has this big cloud of electron density both above and below the plane of that ring. Folks, this is your nucleophile. You have actually 6 options for where you add the electrophile on this benzene ring. For an unsubstituted, plain, old, ordinary aromatic ring, any one of the carbons will do. As long as this is the first thing you're putting on, any one of the carbons will do for your addition. Once you put a substituent on that ring, things change. But that's another video. So, we do the electrophilic addition, and we get here to our first resonance form. All right, so generation of the electrophile, more on that in future videos. Addition to the aromatic ring, like so. Remember, the arrow goes from the aromatic ring to the electrophile. You always track the direction of electron flow. Some of you are still messing up with that, and I don't want you to mess up because that's easy points to lose. So we form another resonance form off of this. Which puts us here. And one more, which puts us here. And I am running out of room like I always do. There we go. And the cation would be there, pi bond there, and pi bond there. Crap. All right. There's our in bracket. All right. So we're going to draw the hybrid for this really quick before we go on to the next step. So the resonance hybrid here would be in any of the forms that have a pi bond at any point, you add electron density. You add the dashed line for where the electrons are, and then you show the electrophile added here. Yes, you should keep up with that hydrogen. More on why in a minute. And partial charges wherever there is a full charge in any of the resonance contributors. Okay, there you go. That's fairly easy. So let's deal with the last step. Remember, the first was making the electrophile. The second was using the attacking the electrophile with the aromatic ring. Third, resonance, resonance, resonance. I just felt like making you draw the hybrid. And now we are going into our last step, which was what? What was our last step? That's right, an E1 type elimination. Now, I'm choosing to eliminate from this structure. You could eliminate from any of those resonance contributors, and you would have the same answer. So a base pulls off this proton, the electrons form a new pi bond, and in the process, you make this. Okay, couple quick reminders of things. Because this was an unsubstituted aromatic ring, that means that all those 6 sites are available. What base are we using here? Honestly, any base will do, and here's why. Remember, in all these reactions, you have to think about the sum energy of all of the possible configurations here, right? Thank you. Yeah, right. So what we need to do, looking at this, is you're breaking aromaticity, going from here to there. Aromaticity is broken. We resonate around, then we eliminate, and we wind up back here. Here, our aromaticity is regenerated. So you're going from something really high in energy with that carbocation to something much lower in energy when you've remade your aromaticity. So any base will do here. Morning breath will pull that proton off to generate the pi bond and reform your aromaticity. All right. One other thing I would like you to note is in this resonance form right here, you'll notice that every other atom pattern that we've talked about earlier is present in full force. Folks, get used to doing that around an aromatic ring. Okay, so what we're going to talk about next, and this is more of a preview of coming attractions than anything else, is we're going to talk about the electrophiles. All the various electrophiles that we can use for EAS reactions. Then we're going to talk about what the products are. And we're going to start everything on a naked aromatic ring. Then, after that, we start talking about the reaction on a substituted ring. reaction onto an already substituted ring. And there's two things that we need to think about with this. One of them is activation, deactivation, and another is direction. Now, if I had to make a guess, I think all of the electrophiles will take up about 2 lectures, maybe 3 if we do a lot with what the products are. Reactions onto a substituted ring, folks, this is going to take as long as it takes. I'm not going to try to make 14-minute, 59-second videos that you have to consume. I try to put these into bite-sized chunks. So that's kind of what we have looking forward. And then, ladies and gentlemen, this is the end of new material for our class. So, congratulations. And then what I hope to do is we have all the new material in your hands by Monday of next week. And then we can spend the rest of the week. I'll put together a preview of what the test could look like. We might do a few review videos and all of that. And then you will have done something singular in the history of this university. That is, you have survived a class online, especially Organic 2. All right? So, that being said, have a good day, everybody. Stay healthy, stay safe, stay hydrated.